Alright, the other thing that we want to do is to prove that the diagonals are congruent to each other, which means that we need to draw in the diagonals, plural. So it's always helpful when it talks about something because then you know what to draw. The one on the previous one, you had to think a little bit. You had to kind of be creative in terms of how it is that you would do that. This one is like, well, it says diagonals, draw them both. Now, the reason we're doing this one right after this one is we want to use this information to help us with this here. So we're going to start with our given. And before we go all crazy, we really need to figure out which triangles are going to be helpful. So I can prove that these are equal to each other, but that is not going to be able to say that this is equal to this. I need to talk about a triangle that has this triangle as a part of it, or that, I'm sorry, this diagonal as a part of it, and I need to talk about another triangle that has that diagonal as a part of it. So I can do those guys. And when I did the video for the rectangles, I didn't really show my options, so I want to show you this one here. I could also do this one because this is a part of that, and I also could do this one because that's a part of that. So I'm just going to go ahead and do those two, and I will do some color coding to help here. So we'll do our yellow triangle, which will give us our yellow diagonal, and we'll do our orange triangle, which will give us our orange diagonal. So those are the two triangles that we're going to choose. Again, we could have chosen the top two, it doesn't really matter, everything's good. So let's look at the two triangles and see what parts we know. It's isosceles, that's our definition. Our theorem says that this in the orange is equal to this in the yellow. So angle ADC and angle BCD, and that is theorem, base angles are equal. And I need one more thing, reflexive. Oh, you know what we forgot to do? We need to draw AC and DC. So again, I don't have to be specific about drawing them like I did here, where I had to talk about, oh, I'm going to draw them right. Here, I'm just connecting lines, or vertices, so I can just go ahead and draw them. So, reflexive, BC, or DC. So, what's my picture? Side and side. So now look at these triangles here. AC is a line segment in that triangle. That's the yellow one. And the orange one, DB, is a line segment in there. So I can say that AC is equal to BD because I have my appropriate congruent triangles. Hurts. Now, the reason I wanted those parts is those are the diagonals, not perpendicular, congruent. And so I can say definition of what? Definition of diagonals. I'm saying, well, these are the ones I'm talking about because those are my diagonals. Alrighty.